Welcome, everybody. I'm still waiting a bit because I see a lot of people are still coming in. So give us a few minutes to let everybody arrive, and then we can get started. Louise, can you confirm that the lobby is empty now?
Yes, everyone who was waiting has been let in now.
Okay.
And I'm still letting people in.
So maybe I can just already start with the welcome word until everybody's there. I'm very happy to see that so many people subscribed because, yeah, we've been working, both of the project that we'll be presenting today have been working for 1 year very intensively on synthesizing results of research on how soil management and cropping systems can actually affect soil functions, impact them. And we will present you the results of this synthesizing action today. For Climasoma, the focus was really on climate adaptation and more specifically even on water regulation. So you'll see the results of that later. And we focused mainly on research that was out there already. Whereas in SoMPE, the scope was broader. It was more on all the soil functions. And in that project, also other types of information were included, like surveys, stakeholder information, grey literature, in addition to the research or the literature that was out there. So, yeah, I think that I can get started, Louisa. Do you confirm, or do you want me to wait a bit more?
No, I'd say go ahead.
No?
I will keep
Yeah.
letting people in once they arrive.
Okay. So everybody just sees my screen, right?
Yes.
Yes.
Yeah, good. I make myself a bit smaller, but you can still see me when I'm talking. So I will be presenting as a coordinator of the project Climasoma. I will be presenting our results, but of course these are results of a very big team. At the end of the presentation, I will show a bit of which countries we come and the different partners. And I want to stress that actually all the work that has been done is really, yeah, part of the work that has been done by many hands. I'm just the one who is speaking about it today. First, I have to find out how I can change the slides. Yeah, that's fine. So to start with, I wanted to set the context a bit for Climasoma. The thing is that we all start to notice actually that the climate is changing. We used to talk about it a lot, but now we see it every year. These are just two pictures taken very recently close to my home here in Flanders, Belgium. At the left side, you see the dry picture. It's a clay soil near to the coast in the polder area. Yeah, where that's just taken this week actually, where the cracks are about 20 centimeters deep. The drought is hitting again, and it's already the 5th time in 6 years that we have this kind of condition. So yeah, that's quite worrisome. And the same actually, but in the other extreme is also happening. Like last year, this is taken just close to my home in a field here in the neighborhood, where we could see wet conditions all around that were quite problematic in some contexts and even leading to severe flooding in some areas. Luckily not in my hometown, but we all experienced the floods also in 21. So the idea is that apart from, of course, keeping on looking at mitigating climate change, which remains, of course, very important, you also need to adapt to it, and that became a reality. And we actually think with our consortium, and also I think the whole of EJP Soil is convinced of that, that soil has a crucial role to play in this adaptation. And in this project, what we actually wanted to do is look at the soil and its structure as a central property or central characteristic which needs to be considered when you look at the impacts of soil management on these soil functions and its role in climate adaptation. Because soil structure, it's maybe a physical property. Yeah, it's the connectivity, the pores of the soil, how they are constituted, but it's linked with all the other processes, with the biological characteristics, but also chemical and other physical characteristics. So we think it's central, and that's why in the literature we looked for all the evidence actually that was related to soil structure and its indicators, and how all these practices and cropping systems were affecting these indicators, leading to soil structures and then the soil functions the hydrological soil functions that were related to it. But before going into the details of our study, I actually wanted to invite you to go to this Mentimeter poll. So you can either go to this website and insert the number that is on the slide, or use the QR code to go there. And then I wanted to invite you to just give your idea on how the practices that we put there are affecting two soil properties or two processes, let's say. Like, one is the plant available water, the other is runoff. You'll see that you can either say, well, it's positively affected or negatively affected by this practice. And then we will summarize at the end what the public was thinking about these practices and what we then found in the scientific literature. Is that working? Is somebody testing that? And can you just signal me whether you get into this poll? Louisa maybe, or Fred?
Yes, I do get in.
Yeah. So maybe look also in the chat if people have problems, then you can maybe help them. I'm not going to wait for the results, so you can do this while I'm talking, and I'll come
Sarah,
back to that.
Sorry to interrupt, Sarah.
Yeah.
Guillaume is asking if you can move a little because your head is in
Yeah.
front of the QR code right
Yeah.
now.
That's good. Like this, maybe.
Yes,
Okay.
much better. Thank you.
So I'll leave it a few more seconds so that you can use the QR code. But otherwise, maybe you can still put the number in the chat, Louisa, if people arrive a bit later, that they can still find it. Can I continue? Yeah. Okay. So the context, as I said already, ClimaSOMA was a project that was aimed at synthesizing existing evidence based on scientific literature. And also, what I didn't say yet is that it was for Europe. So we really tried to focus on evidence that came from the European Union. So the focus we had was on the effect of agricultural practices in the broad sense. So that's really things like management, like tillage or the type of irrigation, but also the crops that were implemented or rotations or things like that. And their effect on soil parameters. So the variables were certain soil parameters. And all those parameters were parameters that we thought were linked in some way to soil structure or hydrological functioning of soil. With that, we also took into account existing policy. I'm not going to talk a lot about that today, but in our report, there's a whole overview actually on the existing policy instrument in the EU and how they actually can be used to affect the practices that we have been looking at, but also to farmer perception and how that also plays a crucial role in climate adaptation through soil management. So the aim of that is, of course, to come towards a more climate resilient agriculture. And as you see in the circles here, I think it's important to see all these things together. Huh? So we look at soil, but we see we look at it as affected by certain practices. And we also looked very briefly, because I have to say this is only a start, we looked very briefly at the social drivers, which also played a huge role in affecting these practices and then ultimately these soil functions. I'm going to start with the part of the project which is the review of meta-analysis, because that's already important to say. You can see also here all the authors, all the people that worked on this chapter. The idea here was it would have been impossible to look at all the primary studies, all the research studies that have been done on all the different practices that we can imagine. So what we did is we said, let's focus on all the meta-analysis that are already present. And what is a meta-analysis? It's actually a paper in which authors summarize in a quantitative way already the evidence that is present about a certain topic. So, for example, a meta-analysis on the effect of reduced tillage or meta-analysis on the effect of irrigation. Like that, we had quite a lot of studies, and they, of course, already summarize what came out of tens or even hundreds of primary studies that are underlying their quantitative analysis. That's already important to realize. How did we then decide which meta-analysis to look at? Well, in the first place, we had this very chaotic sets of meetings, actually. I think the consortium remembers. You can see that at the left side of the slide. Maybe I should move my head again so that you can see that one now. It's very small, but it's just to show you that actually we worked in a brainstorm way on, okay, what are the practices we have to look at? What are the processes we want to take into account or should take into account? And then what kind of indicators or cell properties are related to these or can tell us something about how they evolve. And you can see a lot of post-its there. We tried then to organize them in certain zones and certain practices. And from that, actually, after a few meetings, we then came to a list of keywords that we use then to find meta-analysis papers. And this was then a fixed list that we worked with and that we use for the further analysis. Again, it's not the idea that you read all of this and that you remember it, but just to show that, we really worked quite some time on finding the right keywords to really come to a meaningful, but yet also, feasible list of papers to analyze. Okay, my slide doesn't move now. Yes. Another important thing that I want to tell before I show you the results is that we then also analyzed the quality of this paper, these papers that we selected then. Actually, there's a few frameworks out there that give a set of criteria that you should follow actually when you do a meta-analysis. Some of them are very long. In the beginning, we tried those international standards that we found, but the problem with those very long lists is that it becomes almost impossible to assess for most of these meta-analysis. So in the end, we decided to follow the approach of the paper of Bellouin et al. It's a more limited set of quality criteria that are also in the other lists and that give a good idea actually of the different aspects that one needs to take into account. And what you see immediately here in this graph is you see these criteria on the y-axis. You see the percentage of the meta-analysis that we selected that is doing that exactly. And then you see that some of the criteria are not met. For example, none of the meta-analysis really give clearly the studies that they excluded at some point from their study. So that's already an important one. There's also a lack of, or the studies also never publish a protocol before the meta-analysis on how they did their study. There are basically also some guidelines or some protocols already out there, some standards that you can follow and that you can say, okay, we choose this way of working and then we don't change that anymore because that could lead to bias again in the analysis. So also this is something that is currently not done in the meta-analysis that we found. So that's good to realize, but also some other aspects are fairly well done in almost all the studies. So I think it's important to realize that there are some criteria out there and that we should more and more also try to check for ourselves whether we comply to these. Then to the studies we selected, you can see here in the graph the publication year and the number of studies. The orange color shows the number of meta-analysis of the ones that we selected. So in total, we had 36 meta-analysis that we selected for our project. And you can see in blue all the primary studies that were actually included in those meta-analysis. So you see that it's only in after 2015 actually that most of the meta-analysis were published, and that's also something you see in general. This became popular about 10 years ago, and before there were much less meta-analysis present, but luckily the primary studies indeed range over a whole a few decades actually. Good. Then a final thing that's important for the methodology is also the redundancy analysis. So what we also did when we looked at the papers is to check whether there was not too much overlap in the primary studies that were used to produce these meta-analysis, because that would of course be a problem if you count if two different papers use the same data sets to say the same things. We should not count them twice in our analysis. And so you see that for most of them, it's fine, but there are some that are actually 100% sharing the same primary studies. That could be because there is also a slightly different focus, but still that's a bit worrisome, of course. And if you talk about these studies, we have to take into account that we don't weigh their outcomes twice to make a conclusion. Okay, so then what does a meta-analysis typically do? In the end, they want to see effect sizes. What's an effect size? That can be different metrics, but in most of the papers, what people do is they have a certain practice that they study, for example. Let's take a tillage, reduced tillage now, and then they have a reference. That's conventional tillage, whatever that may mean, of course. I think that can be already a discussion on its own. What's the reference? But then the effect ratio or the effect size would be the ratio of the effect of reduced tillage divided by the effects on the variable that we're looking at in the conventional reference situation. And so that's what most meta-analysis give as output, and that's what we actually use. So in this graph, you can actually see this is the main summary, let's say, of all the things that we put together. On the y-axis, you can see the different drivers, so that are being the practices and the cropping systems that we studied. So you see cropping systems, you see whether or not it's grazed. You see different tillage techniques, different amendments, and also different irrigation techniques. And at the bottom, you see more these soil properties that we took into account. Things that are related to pore space, things that are related to hydraulic functioning, also mechanical properties of soil that are in some way related to structure, of course. Also things related to the water balance. And yeah, so that's what you see in this graph here. And so the dots, that's maybe also important to explain. The size of the dots shows the number of effect sizes that we found in the different meta-analysis for that particular practice and that particular driver. The size is therefore not showing the real effect size of all these studies together, because for that statistically you would have to put all the primary studies that we found in all those studies again in a big database and recalculate the effect sizes. No, what you see here is rather the amount of studies that reported such an effect size. So that means that if two meta-analyses have reported an effect size for, I'm saying something, no-till combined with bulk density, then you will see two different colors in the dot, and the size will reflect the amount of studies that have reported something on that. Okay, so the first thing here in this graph that it's important to note is that there is also quite a lot of white spaces. And I think that's the first important outcome of the project, and it was also actually meant for EJP SOIL as a kind of guide for the future, for future research. You see the knowledge gaps here, right? White doesn't mean, or when there's no dot, it doesn't mean that there is no knowledge yet out there. Of course, there can be a lot of primary studies, but just no meta-analysis yet. So that's sometimes the case. But in some cases, it also just means that there is not so much literature yet available on that combination of driver and variable. So that can be a first way to assess, okay, where are we lacking knowledge, or where should we do more work to synthesize what's already out there? The second thing that you see is that for some practices, there's quite a lot of information already available. Like, for example, the line of cover crop, you see that for quite a lot of different variables, you can find meta-analysis also for tillage, certain types of tillage, or, for example, biochar. And if you go then a bit more into detail to understand what you see there here, for example, if I take the combination of no-till with bulk density, you can see that according to all the meta-analysis that we found, no-till has a positive effect on bulk density, or when it's gray, also neutral is possible. So that means that some meta-analyses have shown positive, other report neutral. How is that possible? Of course, as we do not merge all the results of different meta-analysis, it could be that some of these studies are taking, or some of these meta-analysis are analyzing a different context, for example, which then makes that for them, the result is neutral on average, and for others, it's positive. So what we don't get in this graph is the context specificness, right? We just can see sometimes a hint of it when we see different colors, but basically here you only see average behavior, which is, of course, just the first way of looking at it. As we know, soil is always context dependent. Another example is the biochar. So here, for example, we see that biochar seems to have a negative effect on bulk density in most cases, but again, some other meta-analysis give them a neutral effect. So yeah, just to explain a bit how this works. I think if you're interested in this, I would just yeah, I would just go to the report, take the graph when you have some time, and then try to analyze a bit the different combinations in which you're interested to see what the outcome of the project, if there's a lot of information in this graph. What we then did, yeah, that's maybe also important to notice. So here I speak of positive or negative effects. That's really in terms of the relationship. So it doesn't mean anything in terms of value. So negative just means a negative relationship between biochar and bulk density, for example, in this case. If we then try to translate for a few practices that are where there's a lot of evidence, if we then try to translate that to beneficial or detrimental, this is what we get. So we made a summary more for a policy context and for a larger communication. So there you can see in this graph that for organic amendments, also for tillage and for cover crops, we took out some key variables, and you can see the overall effects that can be expected from the evidence. What's nice to see in this graph is that sometimes things that we take for granted, that there's a lot of communication everywhere, that reduced tillage would be better for all types of things, for water regulation, soil structure, and so on. But we do find, for example, here a clear detrimental effect on bulk density. Of course, again, we have to always think about the context of these studies. So often in most studies, we are talking about measurements in superficial parts of the soil. So we cannot say anything about what's happening deeper down. So again, that's pointing out that the context is also key, and that also in reporting or doing certain measurements, we still have some work to do to really understand what these practices, what's the value of these practices. But it also helps us already to really see, okay, what kind of evidence do we already have on certain practices. What's quite funny is when you show this to a farmer, what I actually did a few times, is that they say, yeah, that's something that my grandfather already knew. We know that we have to put organic amendments. We know that it's probably better to till less and so on. So it made me laugh, but on the other hand, yeah, that's true. But I think in a lot of cases, also these practices are not necessarily implemented, and it's nice to be able to show that scientifically we can back up some of these things. Okay, let's go to the poll now. That's what you actually filled out here at the left side. I think, let's see whether that now works. Is it updating? I don't have so many results. I probably will have to repeat. I will also copy the final graph afterwards in the chat, maybe when I finish my talk, but this is already of a few people at least. So that's what you guys put here, what you thought was the reality. And here I tried to put a bit what we found in the evidence. And then you can see that most things are rather well estimated by the public, but that, for example, on cover crops, often we forget that actually there's a lot of positive effects, but the negative thing is related to the fact that the plants also, of course, take up water. And that's probably the reason why in Mediterranean countries or in the south of Europe, this is much less implemented than in the north, because when you have a lot of problems with drought, putting cover crop is maybe not always the best for your water availability. So that's a thing that you also see back here in this graph. Okay. This was mainly it's not changing. Yeah. This was mainly the result of the meta-analysis. In the project, we actually wanted to go further. The ambition of Climasoma was to actually go into these details of the context-specific relationships. At the start, we thought, okay, if we build a database of primary studies, we can show at least for one combination of, or for one variable or a few target variables, how it was affected by these practices. And so we tried to really build that database of primary studies and all the primary data that was available, and we wanted to apply some machine learning algorithms on those. That was mainly done by John, Lucas, and Guillaume, this work. So I'm also just talking about it, and I would just suggest, if you have detailed questions about it, they're probably here in the audience, you can ask them afterwards. The idea here was to focus on the hydraulic conductivity of soil, because that's driving an important process, which is the infiltration of water into the soil. And there's already a big database, actually, an analysis of saturated hydraulic conductivity. But what was not present there before was a database of the near saturation hydraulic conductivity. And why is it important to not only look at the saturated one? Well, I will show you also in the data, but the idea is actually that saturated hydraulic conductivity is the water then uses the soil structure in its entire form. So it uses the macropores and the micropores, whereas when it gets drier, a part of that porous matrix is not used anymore, and so it can change the relationships actually with the processes. This is just showing that, a tension discal filtrometer, that's the kind of data that we used in the database or that we search for in the literature, is actually then measuring this infiltration capacity or the hydraulic conductivity at different tensions. So from wetter to drier, you can say, or from drier to wetter here in this graph. And for these different values, every time you get the hydraulic conductivity. So this time we didn't only do it for Europe because, as you probably know, for machine learning, it's important to have a large database. So we thought, okay, it's maybe better to include all the data we can find, which is still not a lot. I will show you just after. But this is an overview of where the data comes from. And I think this is actually the main result that that I want to show you. There's a lot more, but it's quite detailed. So again, I would refer to the chapter, the actual chapter in the report for that. But what you see here is two things. Basically, this is the correlation matrix. So you see different drivers or things like temperature. These are climatic drivers, precipitation and so on. And you also see some soil properties there and their correlations with the hydraulic conductivity at different tensions. So at the left, Ks is saturated hydraulic conductivity, and then we go drier and drier to K10. What I want you to look at here is two things: the values, so the magnitude of the values, that shows the magnitude of the correlation, and then you directly see that it's mainly the temperature and the aridity index, who are actually also correlated with each other, that are correlating strongly with hydraulic conductivity, which is already a first important point, actually, that we see that the soil parameters are less correlated with the hydraulic conductivity than some climatic drivers. That's actually quite interesting, I think. And then another thing that you see is that if you look at the different tensions, so the different columns, at around between 1 and 2 there, you can see that there's sometimes a shift, or even before, between S and 1. So sometimes the relationship with the saturated hydraulic conductivity has another sign, so it's positive or negative, and it's inverting when you go to a drier context. That you see that, for example, in the correlation with soil organic carbon, you see it with aridity index, precipitation, temperature, and there that's actually clearly shows that there is this shift from macroporosity and how that affects infiltration, and then to the more the finer pores and the other part of the matrix, which then takes over. And this can actually completely change the behavior or the direction of the relationship. What we then did is some machine learning. I will refrain from explaining it all because actually it was quite disappointing, I must be honest. So the database was very large and we put a lot of effort in making it. But what actually we could show then some correlations with hydraulic conductivity and so on, some context-specific things. But actually, we failed at being able to predict which hydraulic conductivity would then occur in a new situation. So for a certain context, we were not able to train an algorithm that would then predict, okay, for these conditions, you would get this evolution of hydraulic conductivity. And the main reason for that is that, or there's two reasons. The database is still not large enough. So the data is, we need much more data to really train such an algorithm correctly. But also because very often in the studies, information is lacking on some of the metadata. So, for example, if an experiment does not mention the depth of tillage, but just says the soil was tilled, or not when the soil was tilled, or a lot of the metadata is missing, then it becomes impossible and also to train an algorithm that needs those context-specific elements to explain their effect on the variable. So doing analysis on context-specific information is quite challenging. And the final thing there was also that we could actually see that for these soil physical data that are often, things that are related to soil physics, like hydraulic conductivity, different experiments or different experimenters also affected the data. And this is, of course, also a problem. If you have an experimenter bias, in addition to all other contexts that you want to find out, then it becomes hard to predict the outcome. And then I want to finish with the part on farmer perceptions very shortly. That was done by our colleagues from Wageningen. Sinead is probably also here. I don't know about Jan, but in any case, again, if you have questions about them, don't hesitate to ask them. What they actually did is to try to find out what are farmer preferences for adaptation measures and how they are affected, or why certain farmers choose to do certain things or not. And this was a very short and low budget study. So we mainly relied on some key reports and things in literature again. And here I show you one of the things that was very interesting. That was the outcome of the Agri-Adapt project. Here you see how different farmers from different regions, you see the colors that are the regions, how they actually are inclined to adopt certain practices. And first of all, it's quite clear that this context of climate change adaptation, still remains something that's often not the main entry point for farmers, and especially not soil. So climate adaptation is one, and soil is even less often the first entry point. And you can see here that some of them are also quite different between regions. So not only between farmers or types of farms, but also between where they are situated. So that's quite important. We used all this information actually also to make some policy briefs. These are also available on the EJP SOIL website. And there we combined in two different policy briefs actually the results of the biophysical analysis, the meta-analysis that I just presented, and also the results of the policy and the social study. And these are the main outcomes. For example, we say that it's very important to incentivize as much as possible a year-round soil cover. That can be with mulch, but especially with living plants, we could see. And this can be in all types of ways. It can be cover crops, but it can also be introducing intercropping in vineyards, or it can be, the idea is just that in space and time, the soil gets covered. That's really important, as we see in the studies. Another aspect is quite logical, but make sure organic matter from agricultural activities for sure can stay and return to the soil. That's very important, and it should be encouraged. Also there, of course, there's a lot of challenges, and it's not always available, this organic material, but the point is that at least what's there should not be removed, I think. Another thing was on this tillage that we often say, okay, reduce tillage or no tillage is the holy grail. What we really see is that it's mainly a reduction of traffic that would be very important than to focus only on this reduction of tillage. So to go less on the field, to compact the soil less with different types of farming actions or management actions would be a more important focus, let's say. Farmer engagement is crucial, we saw too, and you cannot expect just to come with scientific evidence, like I'm showing right now. This is not enough to convince people, and different people have different needs. So it's quite like in our real world, in our world, everybody is different. It's the same for farmers. There is no one farmer, so we also should not think that we can talk in one way to all the group of all the farmers and then expect our practices to get adopted. Another point is that we really saw that there's a lot of policy instruments already available. It's even sometimes very difficult to find still what you need. And so what's basically crucial is to use existing instruments in the CAP and the Green Deal, for example, and make them more efficient and even more used by farmers. Okay, so in our project, the outcome is still that context is key and that no one solution will fit all. This is true for the technologies, but also for the farmers and their landscapes, the different techniques they use. And I think that's also something that we want to pass on to the future projects. If you see what kind of literature already exists now, maybe we should now find out, okay, what is still missing to better understand these context-specific interactions, rather than to try to look at general outcomes. The policy briefs you can find here on the EJP SOIL website. And there's also this infographic that we made to make it a bit more accessible, let's say. So this actually summarizes the main outcome of this meta-analysis and the sociological survey. Then I want to finish with presenting all the people that worked on this project, because I really think we've done a very nice job together. I really like to work with all these people. It was very efficient in 1 year. So that's the people from Sweden, SLU, Wageningen in the Netherlands, CREA in Italy, and Agroscope in Switzerland, and then our Institute ILVO, where I'm myself located. Thanks, that's it. I would say I'm open for questions now.
Yeah, so I will read some questions that came in the chat. I do have to mention we don't have that much time, so I'm not sure we can cover all questions, but I'll start. So Miriam asks, the meta-analysis, is it for all crops and all soil types?
Yeah, normally yes. So the meta-analysis includes all the keywords that I put up. So that can be all types of crops mixed. But as you saw, no forest. We put some, and yeah, we put some exclusions. But all agricultural crops, yes.
Okay, and then a question from Matthias. Isn't it a bit confusing to refer to agricultural practices as drivers when this concept is mostly, I think, used for underlying economic or social structures, etc.?
Well, I don't know. It depends how you formulate a scientific research question. Here, we really were looking at the drives drivers for us is something that drives an impact. And so a management is something active you do to change something, and that will change something in the soil properties. So that's why we call it drivers. But maybe, yeah, maybe it's a mix up with some other vocabulary from other research fields. So we should check whether that's confusing. I didn't know that. So let me know if I can find a better word for that.
Okay, then Rahasekaran, I hope I'm pronouncing that correctly, has two questions. One is about investigator bias, which I think you covered, Sarah. But then the second part is, do you also rate overall quality of meta-analysis over the time, over some years?
We did not make any analysis on that, but basically with the analysis we did, we could do that, because for each study we took, we actually have crossed which of these criteria they comply with. So we could make a graph on how that's how it evolves over time. That's the word I was looking for, how it evolves over time. We didn't do it, but it might be interesting to see, but because probably these standards are often quite recent. And I think the first ones will most probably not comply with them, or only partly. And the newer ones maybe will. So it's only also for me, it was quite new to see that there's really this whole list of standards that you can really check whether you're complying with those. Yeah.
And I see that Matthias has put in the chat that apparently the European Environment Agency has a different use of the word drivers, Sarah, so maybe that's something.
Okay, I'll check it. Yeah, thank you, Matthias.
Yeah, then a question from Elena. I'm just going to read the whole thing. Effect size depends on control reference. For example, in case of biochar, the effect size will be different if you choose NPK fertilization as a reference or zero fertilization. How did you take into account difference in controls and reference across different meta-analyses?
So that's exactly why the size of the circles, we try to do that in the beginning, but it's impossible. That's a good question, very well noticed, Elena. So what we try to do in the beginning is try to find all the primary studies again from all these meta-analyses, and then try to recalculate all those effect sizes, taking into account the right reference and so on. First of all, you don't find all the necessary information in the primary studies, because often the data is not published. So often we could not recalculate. So this database is never got finished. So the idea of our graph is the size is not really showing some kind of composite effect size, because this would be statistically incorrect, as you just noticed. The size just shows how many effect sizes were reported on that one. So the circle only becomes bigger if more papers have computed an effect size on that topic. Do you understand? So it's some kind of pragmatic way to still show, okay, there is more evidence present, but we were not able to recalculate some kind of composite effect size.
Okay, that was actually all the questions, Sarah. I suggest if anyone has a different question or wants more elaboration, you can still put it in the chat, and
Yeah,
Sarah
of
can
course.
maybe now
Yeah, yeah.
follow as well. And that was actually perfect timing because it is now time for Fred's presentation. So there we go.
Hello, everybody. Thank you for being here, and thank you, Sarah, for this clear presentation of ClimaSOMA. I will share my screen now. Hope you can see the first slides of the SoMPE presentation.
Yes.
Yes, okay, thank you. So we will go through the work we did inside our project. It was also 1 year project of a GP, based also center on this study of innovative soil management practice across Europe. And our main aim, and you will see that we explore also other, but we are focused on a kind of inventory of these practices, and how also we have explored also how to diffuse these practices across Europe. So we work, the coordination team was composed by Olivier Heller from Agroscope in Switzerland, Claudia Di Bene, Pasquale Nino in CREA, in Italy, and myself in Wallonia, in Belgium, Wallonia, Sarah W. And you see here all the surveying partners of the project. In fact, we had the chance to have all countries, one partner in each countries of the EJP consortium. For collecting data. So I want to start the presentation here to thanks coordinators and participants of this project. So SoMPE is explore 4 main axes around soil management practice, and during this webinar we will go through these 4 main axes. So the inventory, we will start with that, with the description of the inventory itself. What we did, we the partners of in each country collect data and document list of practices. And in fact, we start with a pre-identified list of practices in the first an early stage of our project, by reviewing other European project or other source, trying to select and remove the double entries, and also understand and classify that in main categories. You see categories here: agricultural system, buffer strips and small landscape elements, crop protection, crop rotation, organic matter, nutrient management, tillage and traffic, water management, or other. And doing that, we identified 58 pre-identified soil management practices that will be a part of the inventory. And you will see that these pre-identified practices will constitute the part A of this inventory. And we collect also data for the part B inventory. In fact, where there are more space from partners in this B inventory to document also smaller innovation, experience, or specific practices, more local or more innovative in their own country. So all these practices, at the end we have 100 practices for the documentation, and in complement of that, for the practices identified in the preliminary studies, in the part A, we have also a kind of screening of the current application in main environmental zones of Europe. You will see that in a part. What you will find inside this inventory will be the description, the current application for part of the inventory, potential area of application with this kind of limitation adaptation factors linked to climate, linked to soils or the sites, the slopes, organic soils, and so on, linked to the land use or the general farming systems. And you will find also information linked to the impacts, potential impacts of the practices. And we based our work for this part also really linked to all these EJP soils challenge that were identified in the whole project. So here it was not the aim of the project to do statistic. It's not real statistic, but it will give you a kind of general ideas of the document practices. Here it's only for the practices in the part A groups. You will see that it fits to lots of European farming systems, but maybe a little less to the smaller farming system. And from medium to large, it was the practice documented inside are more, but in the average, it's really focused on all, more on organic farming, conservation agriculture, lots of practices documented fits in this category, little less for the other, and the lesser one, this specific agroforestry, including animals with or silvopastoral elements, so that's less fit for as a mean. Here also you can see the global results of the land use, and sure it's mainly focused on the non-irrigated arable land, but you can see also that the practices, lots of practices can fit with permanently irrigated land or heterogeneous agricultural land. Lots of part of the fruit and the orchard regions and systems, and you see again less to rice fields. Sure, it's not so common here in Europe, and also natural grassland where less practice can be applied there. Here you can see the application linked to the sloping. So you see also that sure, when it's flat, it's almost all practices are applicable there, and it's decreasing with a kind of jump
Is it frozen just on my side or for everybody?
No, I was going to ask.
I also lost him, yeah.
Sorry, it's
you're back.
Down, but yeah, hopefully it was not too. You see my screen back?
I am just seeing a black screen right now, Fred.
Okay,
I'm
you
not
see.
sure how it is for anyone else.
You see something or not?
Not yet. Sarah, Olivier, do you?
No,
I don't see a screen yet. I just see heads.
It's just black, yeah.
Fred, I'm not sure if you have your camera on. It might help to turn your camera off if you have a bad connection.
Yes, I will shut down my camera.
Yeah, I'm seeing your screen again.
Okay.
Yeah.
Sorry for that. It's shut down and coming back, but you see the slides again?
Yes.
Okay, good. So that was for the slopes, not so. And a link here to the EJP Soil Challenge. You see that for the first inventory, the part A, but in the final report published that will be shared, you will find also this for all the practices. You see that avoid erosion is something really put forward by the practices documented. Enhance soil nutrient retention, use efficiency, optimal soil structure, water capacity, and you see the decreasing importance of the challenge that were identified in EJP That's the in our inventory. And here is other impact. Also we ask for, is it an impact on crop yields or farm profitability or other. That's for a flavor of the inventory. I will not go in too much details. For the part B, people were free to document new things, sometimes linked to the first one, but with some innovation and so on. And you see in this second sets of practice more freely chosen by surveyor, lots of practice linked to organic matter, nutrient management, crops and crop rotation, tillage traffic, and you see also here the decreasing topics of all of this group of practice. I will show at the end of the presentation just some way to explore the inventory. One part of this inventory was the current application. Just again, here we use this theory of Roger for the adoption, the diffusion of innovation, where some farmers are really early adopters, innovators, early adopters. Then you have the early majority, late majority, and the old people. And so for the pre-identified practices, we ask that to all part of Europe, inside each country, and inside each country for the various environmental zones of EJP also that will be present just after. But you see, we produce maps, and you will have the data also in other forms, in data sets and so on. But you see here for organic farming, something homogeneous. For biochar, you see something that less applied across Europe, and other practices are really more variably applied in Europe. So the database will be in open data available, and I will, at the end of the presentation, I will show also you how it will be shared to explore this data with reactive application and so on. And maybe it will be version, so we can update this through the time to add data, more information, or see evolution of some practices. Now we arrive at this third part of our presentation with the biophysical limitation. And for that, I will let the screen to Olivier, my colleague Olivier from Agroscope.
Yes. Do you hear me already and see me, or also see my screen by now?
Yes, we see the screen.
Okay, so I start the presentation. Just one moment. So perfect. So thank you very much, Fred, for the introduction and the presenting of the first parts of the work that we did within SoMPE. So I focus for the next 5 to maximum 7 minutes to the biophysical limitations that might apply to the spread of certain practices. So as Fred mentioned before, or at least showed on the one slide, there are many reasons why a practice is not applied at a certain area. And of course, this might be due to biophysical limitations, or it could also be to other socioeconomic barriers. But Fred will later on talk about the socioeconomic part. Here we rather focus on the biophysical part. So we first started with some views into the literature and identified factors, biophysical factors that might limit the application of certain soil management practices. And of course, there is land use. So from this image, you can already see that maybe a practice is applicable just on arable land or in grassland, and it might be hindered, for example, by agroforestry systems where you have some trees within the area or within the land that might limit the application of a certain practice, or maybe the trees are very necessary for this certain practice. So land use for sure is an important factor here. Then of course, climate, which varies across Europe, widely across Europe, can also limit the application of certain practices. Again, on the image, you could imagine that further up where there is still some snow in the mountains, it's probably hard or not the same practices are applicable compared to the lower areas. Of course, you also have the same for a gradient from south to north and from east to west within Europe. And then, of course, topography, mainly the slope, can affect the applicability of certain practices. So the steeper it gets, in general, the fewer practices can be applied on a certain area or in a certain region. And fourth, of course, soil properties can strongly limit the application of the beneficial effects of certain practices. So again, if we come to the image itself, already on this very small area, you have multiple soil types that can strongly vary also in soil properties like clay content, soil organic matter content, and also the soil hydrological characteristics throughout the year, for example. So the clay soil and the histosol are most likely more often wet than the cambisol that we have over here. And for our assessment of this potential area of application, where the application of a practice is not limited by a certain factor, we wanted to base this on, or we wanted to be as quantitative and as spatially explicit as possible. Therefore, we based our approach on geodata that was available, and we assessed this not on the, let's say, not on the level of the farm or on the field, but on the level of these agroecological zones across Europe, so on a rather large scale. And we applied this framework to some case studies that we had in the inventory, but of course it could be used also in different contexts on a smaller area of or level of aggregation. So for example, on within country regions, or even to the farm level in principle. And it could also be applied, of course, to other case study practices. So in the next few slides, I show you or give you a brief overview about this framework that we started to develop within SoMPE, and that we applied to one practice that I show you here in the presentation. So of course, we first started with a short review on other projects that had already been done in Europe and where such agroecological zonations have been made, and we tried to learn as much from them as possible while developing our own, or the system that we applied for SoMPE. So we looked at a few projects and looked at their zonation, and found that none of these existing zonations is very helpful to us, because either they did not cover all the countries that we were interested in, or because, as you know, EJP soil is covering a lot, or is covering about 24 countries in Europe, but we extended the area of interest to the 45 countries within Europe. So these countries, or these approaches, the earlier approaches did not fit with all of this. And then we have one project, the ISQUAPER project, where there were different zonations used than within EJP soil. So not the zones by Metzger et al. From 2005, but the zones from Hartwich et al. So this was also not applicable. Therefore, we started basically with our own, or with a new definition of agroecological zones for the purpose of our study. And we started off with these 13 environmental zones by Metzger, which are pretty well known and also widely used throughout many approaches, including many EJP soil projects. And we basically cut them by country borders, or Belgium regions for that matter, and then ended up with 146 agroecological zones, where these are also the zones we asked our partners for the spreading, the current spreading of the practices. And then we characterized all of these agroecological zones based on the land use that is there, different climate aspects that there are. So let's say rather simple ones like average temperature, average precipitation, evapotranspiration, but also a bit more complex one like temperature sums throughout the year, annual weather balances, number of days above 30 degrees Celsius, etc. And this was all based on the last 30-year averages from 1990 to 2020. Yes, and then of course we also used topographic data, so we assessed the slopes throughout all of these areas, and also some soil properties. So just on a simple assessment, basically, where do we have organic soils and where do we have mineral soils? And then again, more complicated or more complex data on different soil types, textures, rooting depth. But again, here on a very coarse level, derived from the European Soil Database. And basically with all of this, we did zonal statistics for all these environmental zones throughout the country. So this 146 environmental zones, and then again for the different land uses within each zone, and basically calculate relatively large tables where it was afterwards possible to make certain assessments basically. So for example, if you would be interested how much of the arable land in Switzerland is situated in Cambisol, we could just look up this in the table and say, well, it's about 4,200 square kilometers. Or if you would be interested, for example, of how much of the non-irrigated arable land in Poland has a slope below 2%, we now can relatively easily say, well, it's 62%. And so this data is all there, it's all available, and it could also be used in different contexts, not just within SoMPE. And as I said, we also applied the framework to multiple practices. I highlight here just the application to cover crops. So for cover crops, there are multiple criteria. One, of course, is that the climates need to be suitable to grow a cover crop after another crop, so after the main crop that the farmer is interested for selling. So we made some very simple assumptions and applied them to the data that we had available. So first, we assumed that the cover crop needs or wants to be grown after winter wheat, and that the winter needs a certain temperature sum to maturity, and that after this the cover crop can be sown. So first we calculated when is the temperature sum of 440 degrees reached throughout Europe, and you see the spread that basically it's earlier the further south you go and later the further north you go. And then we calculated how many days have suitable temperature for cover crop growth. So we assume this above 5 degrees Celsius average daily temperature, and calculated the number of days that are suitable after this harvest of the winter wheat until the end of the growing period, so to say. And then again, from this, we subtracted all the days that are too dry to grow cover crops because the precipitation is below the potential evapotranspiration of these days. And therefore, we ended up with a map that shows how many days are available or suitable for cover crop growth after winter wheat harvest based on the assumptions I just showed. And then we calculated what's the average day then per number of days per each of these environmental zones, and assumed that we want to grow the cover crops on arable land and on slopes below 30 degrees 30%, and found that if we assume this and then calculated with the areas that we saw in the tables before, that of all the suitable land use, so all the arable land in Europe or in these countries, about roughly 0.2% are limited by the slope, so have more than 30% slope and are therefore not suitable for cover crop growth. And then if we just look at temperature limitation to cover crop growth, we already see that about 6 to 9%, depending on the amount of days you assume that a cover crop would need to grow, are limited to grow cover crops. So it's already a challenge there. And then if we additionally also consider the moisture limitation to cover crop growth, it's already 40 to 68% of these areas where the growth of cover crop is a challenge after winter wheat. And this is, as you see on this map, mostly, of course, to the north and to the east of the continent. So this is one application of the framework. And now I would like to hand back to Fred. Yeah, and if you have questions, don't hesitate to ask them in the chat or later on also directly to me. Thank you.
Okay, I'm back. You see my screen again? Yes.
Yes.
I hope. Okay, here are some last part of the work. I will go really rapidly as we arrive now at the end of this seminar. But we use a framework based on qualitative surveys that we code, we attribute, we try to identify relationships in these qualitative interviews of experts to build cognitive maps and to trying to understand what's more important concepts of the practice that we try to analyze. The qualitative interview were done by the partners of SoMPE and among not farmers but among experts of the systems that can express themselves on how they see the situation in their country and so on. We use this framework as concepts to trying to understand relationship between elements. That's not the output of our project, that's the framework of farming systems analysis of Darnhofer. And I will show here the example on conservation agriculture, just a few slides, but we have case studies on other practices as well, but conservation agriculture was done at the European level. So you know what is conservation agriculture with the big principles, and this is the kind of outputs we get from the interviews. If a relationship comes in many interviews, it gains the weight. The weight are higher, and you see also that the concepts that links these relationships gain in centrality. The studied practice here is conservation agriculture, and you see around that the centrality of concepts. And we explore the data like that, and you need just to understand that between each relationship we have part of the interviews, so we can understand what is behind every kind of relationships, and we explore that data sets going to go, okay, what are the relationships linked to the knowledge, and we see concepts that are highlighted in the knowledge, in the finance, another type of relationships linked to material, linked to ideals of people, and we try to understand what is important. So we are not going in this graph now, just big conclusion that we get from this kind of analysis, but all details will be available in the reports also. That knowledge is really important, and the importance also of the networks between people. Yes, here. Yes, sure, policies, liquidity, and legislation can help people to adopt practices. And the ideals also linked to the tradition, the gaze of the neighbors, or the expectation of the citizen, and so on. I think it's better to go more in details in the report. But what we have as an output of the project will be the results of the inventory in many ways to explore, open data on Zenodo, but also you see that there are methodological development, so the scripts and program will be also shared on developing platform. Just a small flavor of the application that we will share soon in the newsletter, but you will explore the inventory through this shiny application to explore the information, what I addressed before, with a map, with the slope applicability, land use applicability, the zoom of the map also, where is it applicable in Europe, and so on and so on. So, and the data also. So that will be shared and announced in the newsletter. I think I will conclude now to thank you, and give the floor back to Louise for maybe some question.
Yes, for now I don't see any questions in chat unless I miss anything, in which case please feel free to retype your questions. If you want to raise your hand to ask a question, that's definitely also possible. I see that Claire just asked a question regarding the analysis of biophysical limits for implementing SoMPEs. It's extremely useful for research, including EJP soil projects and beyond. One, are similar analysis and tools available elsewhere? And two, do you need to do additional work for others? For example, other EJP soil projects will be able to use it. Maybe
Maybe Oli, you as it's
Yes.
linked to this part.
So on the first part of the question, I'm not aware of a tool which is directly available. That's also why we thought it is worthwhile to invest some time in this and to make it available. So I think most of the methods are on GitLab at the moment and they're available there. And the results, so basically these tables are on Zenodo freely available. I think the links to all of this are also mentioned in the report. So that's to the first part. And then for the second part, we are already or have been exchanging with the Carbosec project because they also have a part about the applicability of a certain set of practices across Europe. We have been in contact, but I haven't heard in the last few weeks, but I think they will start with working on this in the month to come, as far as I'm aware. But of course, if you know any other projects that would like or that could benefit from this, please, forward them to me, and I'll happily help with however I can.
Okay, thank you. And the second part of the question, Fred, I don't know if you or did.
No, I think
Oli
okay. Answer that also.
Yeah, I think it's
okay, sorry.
With the with what we mentioned in the report, and of course direct questions and answers from our side, it should be feasible to use the basics that are in there. Yeah.
Okay, if there are no other questions, I suggest I will give the floor back to you, Fred, for closing us off.
Yes, thank you. Thank you, Louise. Thank you, Sarah, and thank you, Oli, and other people for the presentation. Thank you to all of the participants for joining us in this meeting, closing work in these two projects, small project inside EJP SOIL, just 1 year, but really intensive, I think, in ClimaSOMA, as well as in SoMPE, with good interaction, good. It really, I think I can point that it's a kind of succeed objective to put people together, to work together, to try to apply methodology, develop new methodology, collect data in new situation, learning process, and so on. That's all things that really interesting. It's good to see now the end, the outputs of the of this project, and I hope, and I think Sarah will be agree with us, and other also, that we hope that it will maybe bring new perspective also for collaboration, for new project inside the EJP SOILs, and to share experience, to apply some part of the methodology in other situations that partners find, okay, this framework can be really interesting for that practices, for another way to explore qualitative data in a small region, or I don't know. But I hope that that will be really interesting to continue this this good project. Thank you for the meeting. Thank you all. I don't know if someone wants to a reaction. If no, I think we can close the meeting. Sarah, something to add, or Claire, or?
Sorry, from my side, everything's fine. I want to stress actually that we were both synthesis projects, and actually the main aim of these projects was to feed into new EJP SOIL projects and feed into new strategies for research and for applications also. So what we really want is that our results are being used by other researchers. So please do go and check it, because it would be really a pity if all this synthesis work would just be for the books. So it's done for the entire community, and I hope it can really help for further research.
Yes. And maybe we will see us some part of us in Palermo in the annual science day or for the annual meeting. We'll see. We can also exchange during these days for people who will attend this. Okay, so I will thanks again, last thanks, and we can leave the chat open. I see already interaction that's really interesting. So maybe not close to directly the meeting, but maybe make connection. I see ask for further interaction. So I will shut down my camera and my micro, but don't hesitate to write something in the chat. Bye bye, everybody.
Thank you, everyone.
Thank
Bye.
you as well. Bye.